Welcome to the session on basic filters. So the term filtering covers all the ways of separating different wavelengths. A filter can be conventionally made from electrical components like capacitors and resistors, or it can be digital filter working with an algorithm giving the same effect as the electronic filter. Let's consider the use of filtering in assessing the surface texture. The assessment of surface texture involves blocking certain wavelengths and accepting others. Since in assessing the surface texture, roughness has got more importance, so we are accepting the roughness and blocking the waviness and form. Consider this figure. So this one is the input signal to the filter, the profile filter, and this contains form, waviness and roughness. But we are blocking certain wavelengths and we are getting actually what is the roughness. So only roughness values are getting as output. Here it is explained some advantages and disadvantages of using the filter. So in advantage side, no prior knowledge of data is needed because a linear operator on profile data irrespective of the nature of the data. Then it is easy to change the characteristics of the filter by moving the frequency domain. But in a disadvantage, there loses data at beginning and end of the assessment length. Just like here. Here also we are losing some data and here also we are losing some data. The process of filtering. So there are two ways of operating, one in space and other in frequency. So in surface metrology utilizes filtering in space, not in time or in frequency. The path A shows the operating in space, but path B is showing the operating in frequency. So path A has got only one step, while path B has got three steps. So in path A, we have got only one step, and that step is known as convolution step, which is a window scanning across the profile. While the path B is a frequency or wavelength domain, this requires three steps as opposed to one in the path A. The two steps are transformations and one is a multiplication. The point here is that transformations by the FFT, that is the fast Fourier transformation routine, is quick compared with the convolution operation. In surface metrology, especially in roughness, it is more visual to use path A because a workpiece exists in space, not in frequency. And path B can be used effectively in roundness filtering because the variation is periodic. Then what is convolution? So convolution is a mathematical operation that is similar to looking at the profile through a window. So in filtering, we are actually moving this window from one position to another over the profile. So the width of the window is equivalent to the sampling length and the shape of the window depends on the type of filter. The symbol of convolution is this one. Now we are considering few of the type of filters which are used in surface roughness analysis. Before going to study the types of filters, we will have some basics on high pass filter and low pass filter. So in high pass filter, it is defined as this filter that passes signals with a frequency higher than a certain cutoff frequency and attenuates or eliminates signals with frequencies lower than the cutoff frequency. So let's consider this circuit diagram of a low high pass filter. So it consists of a capacitance and a resistance connected like this. So the theory is that This capacitance offered a zero resistance to high frequency waves. So it offers no resistance to high frequency. It is passing through and there will be an output. And the resistance of this capacitance is will be infinite. That is very high for low frequency waves, so that will be stopped over here and it is not allowed to pass to the output. So this is a theory, and that is explained in this curve. Again, that is voltage against frequency. So we can see that this is the cutoff frequency. So we will have an output after the cutoff frequency only, and there is no output here. That is the low frequency region. But a low pass filter, these filters are that passes signals with a frequency lower than the selected cutoff frequency. And in construction, it is like this: the resistance is connected like this, and the capacitance is here. So when a high frequency is input is a high frequency signal, this capacitance offer zero resistance to high frequency, so the all charge will be discharged to the ground. So there will not be any output. But for low frequency signals, this capacitance is providing an very huge, that is infinite resistance. So the capacitance is not conducting. So the output, we will have an output over here. So that is a theory. So we will have a output of low frequencies and all high frequencies are filtered out. And this can be seen in this curve. Again, that is the voltage against frequency. So this one is the cutoff frequency. So we will have an output in the low frequency region and there is no output in the high frequency region. In analysis of surface roughness, if we need roughness patterns, we will go for a high pass filter because the frequency of roughness is high. And if we need waviness features, then we will go for a low pass filter. Now we are considering a standard electrical 2CR filter. 2CR means it consists of two capacitors and two resistors connected like this. And this one is the first filter to be used for surface roughness analysis. So this one, by the construction, we know that this one is a high pass filter. So the output will be a high frequency roughness features. These kind of filters has got some undesirable effects in surface roughness analysis. So one is explained as this one is an analog filter and works in time rather than space. So it is an asymmetrical window or weighing function because these filters are working with some weighing function, but here the weighing function is asymmetrical, so which produces a distorted waviness mean line because this mean line should be uh, regular like this. But in this case, we can see that this one is a distorted one, so this is not a regular one. So that is the main disadvantage of using this 2CR filter. Second one is the attenuation characteristics of these filters. So these are too gradual, not a sudden change is not there. It is gradually actually filtering. So this one here, the characteristics is given as lambda. So we need lower lambda. So this one, that is the high frequency range is the required one. That is the roughness, and these are has to be filtered out. So it is not drastically filtering out, it is filtering gradually. So that is also have adverse effect on the final result. So in order to correct the drawbacks of 2CR filter, we are using phase corrected filters. So these are otherwise known as linear phase filters. So in linear phase filters, the window function we are using is actually symmetrical about x value because asymmetry produces mean line distortion. So in order to remove that, we are using a function, window function, symmetrical about the x value. Let's explain the window functions with this figure for both 2CR filter and phase corrected filters. This figure A is which is showing the the weighing function for the 2CR filter, and this is asymmetrical, and this one is the weighing function which are used for phase corrected filters, and these are symmetrical about the x0 value. So finally, in comparison with the 2CR, comparison of 2CR with the phase corrected filters. First one, the attenuation characteristics. So we can see that for 2CR it is too smooth, but in this case it is not too gradual. It has got somewhat it was steeper. Then distorted waviness mean line. Here the mean line is distorted. See, we can see that it has got so many fluctuations and unwanted fluctuations. But here the phase corrected waviness, the mean line is somewhat smooth. So we will have better outputs. Thank you for watching and stay safe.